Awesome. Cool. Hi, everyone. My name is Apu. For those that don't know me, I'm a backend software engineer at Improbable. I've been working for Improbable for about 4 years. And today I'll be talking to you about how to make a HTTP server from scratch in Golang. Sounds ambitious, but don't worry, we'll get through this. Part of what I do at Improbable is that I work on backend systems. So I work on quite a few different HTTP servers. And we at Improbable, we're building this kind of distributed simulation platform for online games. And these online games need to communicate with other things in the cloud. They need to make HTTP requests and kind of gRPC requests. Our own services, our own microservices run in Kubernetes, and they work in a distributed fashion. So they make HTTP requests across the cloud. And what we've seen at Improbable is that when things are working fine, it's awesome. We're happy, the world is green, we're making money, all things are good. What happens is that sometimes things will break in production, and we have an incident. And the scary thing there is, hold on, something is broken in the network, and something crazy has happened. And it's quite intimidating to debug network problems. I don't know if anybody here has kind of debugged network problems in production before, but that can be quite a scary thing to do. And that's kind of unsurprising, because when you look at it, networking has loads of different protocols and quite kind of obtuse names, things like TCP, HTTP, IP, TLS, and a bunch of other really scary kind of isolating sounding acronyms, which kind of all, in my opinion, kind of obfuscate how simple networking is. From my perspective, networking isn't actually that complicated. It's actually pretty simple ideas and pretty kind of intuitive ideas as well. And so the kind of aim behind this talk is to give you an introduction to how networking happens. We're going to do that by building a HTTP server from scratch in Golang. Sounds ambitious. We'll get through it if this talk goes well. And my kind of hope for you guys is that if you're new to Golang or if you're new to networking, you kind of have this whirlwind tour through all these different bits about networking, which I just talked about. You kind of get an understanding about how networking works and kind of get an understanding of what NetHTTP does, which is this awesome package that allows you to make HTTP servers in Golang. And if you're more experienced and you've written Golang before and you have experience networking, my hope is that you'll understand a bit about how the kernel does networking and kind of what bit of the networking stack is done in user space and what bit of the stack is done in the kernel space. Does that make sense to everybody? Yeah. I can see a few nods. Awesome, cool. So let's kick off. So today, we're going to build a server that stores the date of Brexit. It's a Brexit date server. It's mad. I mean, the government can't even do this, but we're going to be ambitious. We're going to try and do this ourselves. It's a really simple server. It's going to be using HTTP 1.1 because HTTP 2 is a bit more complicated, and so is HTTP 3, and that would take 3 hours instead of 30 minutes, which is what I have. We have one route and two methods. That one route is the Brexit date route, and we can either get the Brexit date, and we'll get that Brexit date in the response body, or we can update the Brexit date, and we can actually change what it is, and we can do that using a put request. We're going to first implement this using NetHTTP, which is kind of the de facto package about making HTTP servers in Golang. Super powerful. I'm going to show you how easy it is. And then after that, we're going to make it from scratch ourselves. So let's begin. So what is HTTP? Hopefully most people here have got a good understanding of what HTTP is already, but just to kind of get everybody on the same page, I'll just kind of do a quick TLDR. So HTTP is pretty simple. It's a request and response protocol. We have a server running somewhere in the cloud. That could be in GCP, in AWS. It could be running on Kubernetes. We don't really care. It's running somewhere in the cloud. We have a client somewhere else in the world. That could be my machine. It could be my browser. It could be a CLI tool. Indeed, it could be another server running somewhere else in the world. And then what the client does is that it makes a HTTP request, which it sends to the server. The server handles the request. It might do some logic. It might, for example, look at a database, do a lookup. It might do some kind of computation, et cetera, et cetera. Then it creates a HTTP response. It writes that to the connection, and then the client gets it. And this kind of request and response happens over the public internet. But to keep things simple for this talk today, what I'm going to do is have the server running on my machine, the client also running on my machine, and instead of doing networking over the public internet, we're going to keep the networking to my particular machine, just to keep things simple. So let's do a demo. Let's build a HTTP server using NetHTTP. So let me just pull up some code. So on the right-hand side, we see, can everybody see this code? Can somebody give me a thumbs up in the back if they can see it all right? Yeah, awesome, cool. On the right-hand side, we have the server code. On the left-hand side, we have the client-side code. We have this main function down here, and there's kind of two key functions in NetHTTP we need to call to make a very simple server, and we're going to do it kind of the most basic, most simple way as possible. We're going to call http.handleFunc. This guy takes in two parameters. The first parameter it takes in is a path it should be handling a request on, and the second parameter is a function which it should call whenever somebody makes a request to that path. I'll talk about that function a bit in a sec. But basically, every time I make a get or a put to this guy's going to be invoked. The second thing we need to do is call http.listen and serve. And this guy basically starts up the server. A bit later on in this talk, I'll kind of explain what this guy is doing underneath the hood and kind of, what kind of process calls it's making to the kernel and kind of what's happening internally. But just think about it right now as it's kind of starting the server. Inside of this Brexit date handler function, we have these two parameters, the response writer and the request. We have some debugging over here. We do some really simple logic. So remember the logic up here, which I pointed to you about. We can either get the Brexit date, and we return the Brexit date in the response body. We can put the Brexit date, and we update the Brexit date stored by the server by that was given to us in the request. So that's exactly what we're doing here. If we get a GET request, if we receive a GET request from the client, we're going to write the Brexit date, which is this kind of global variable up here, to our response. If you get a put request, we're going to read what the body of the request is, and then we're going to set that Brexit date variable to be that body right there. So that's pretty simple. That's about 30 lines of code, and we have a pretty simple HTTP server running. And let's have a look at the client. So the client is also pretty straightforward. We do a http.get. That does a get to this URL, which is this server right here. It's listening on localhost 1234. That's this guy here. We're going to go to our Brexit date endpoint, which is the kind of endpoint we're looking for. We read the body that this GET request returns, and then we print it to the standard output. We then update the Brexit date, and we're going to do a put request this time. So we create this put request object. We're going to do http.newRequest. We're going to create a put request object. It's going to go to the same endpoint. And then we're going to do this request. We're actually going to send the contents of this put request to be the 31st of October, which when I wrote these slides originally wasn't the final Brexit deadline, but it is now. So apparently that's going to be Brexit, but there you go. So we're going to put the 31st of October to be the new Brexit deadline. And then we're going to say that's happy and succeeded, and that's about it. But let's run this before I go too far. Let's make sure everything works. So that's in the right directory. This guy's in the right directory. Can everybody see this as well in the back? Yeah, awesome. So I'm going to run my server, and that's my server running. And then I'm going to run my client, and that's my client running. So we have on the server side, the server got a get and then a put request. And the client says, OK, awesome, the Brexit date is 29th of March. It did a put, the put succeeded. I run the client again. What should happen? What kind of Brexit date should I get? Does anybody have an idea? Yeah, 31st of October. So run that again, and yes, 31st of October. So that's pretty awesome. That's a really simple HTTP server that's running in Golang. And it's taking me 30 lines of code on the server side, 30 lines of code on the client side. And that's pretty awesome. That's like one of the really cool things about Golang. We can write something really simple really quickly, and it's pretty elegant. Even if you're new to Golang, and hands up for those of whom of us are new to Golang, I think there's a bunch of us, maybe 20%. This is actually pretty readable, right? This is actually quite easy to understand. And that's one of the really cool things about Golang. It's actually not very complicated. You can write very, very elegant things pretty easily, and it's actually quite intuitive. And this is kind of like one of the key points about Golang. You can write quite complicated code, much more complicated than this, but it still remains quite readable and quite understandable. And this is kind of like one of the design patterns behind Golang. I don't know if you guys have heard about Rob Pike. He was one of the founders of Golang. And he has this talk, which is a really interesting talk called Simplicity is Complicated. And in that, he kind of motivates about how Golang is designed and what kind of opinions it has. And one of the opinions it has is that it does things in one particular way. It doesn't offer many routes to do one certain thing. It offers one way of doing things. It's very opinionated about how you use the language, and it has like a very precise use case. And with having like a very precise use case and a very precise usage, it's actually very simple to read and understand as a user, which is fantastic. And I really recommend that talk if anybody's interested about why Golang was designed the way it was. It's really interesting to kind of understand. But going back to kind of this talk, imagine this server is running for your company in the cloud somewhere. And imagine for some reason it breaks. There could be so many different reasons why it breaks. And kind of the rest of the talk is going to be us creating this from scratch. And hopefully what we'll see is, we'll kind of understand what NetHTTP is doing, and we'll have a better understanding of debugging it and fixing it when it goes wrong. Does that kind of make sense to everybody? Awesome. So if we continue, so what am I talking about today? So I told you about the Brexit deadline server. That guy's pretty simple. He has one endpoint, and he has two requests on those endpoints, a get and a put. The next thing we're going to do is create a TCP server and client using Netcon, which is like another low-level package inside of Golang. I'll talk about Netcon as well a bit later on. And then the final thing we do is that we'll implement HTTP server and client ourselves using that TCP connection that we just created. So let's continue. So what is TCP? So everybody here knows about HTTP. We kind of briefly covered it earlier. TCP is different to HTTP. It's kind of the protocol on which HTTP is built upon. And HTTP is a request-response protocol. So a client sends a request to a server, the server handles it, and then sends it back a response to the client. TCP is a bit different. In TCP, there is a byte stream between the client and the server. They make a connection with one another, and the client can write at any time to the server, and the server can write at any time to the client. They just write to the connection. And either guy can read from the connection at any point. So it's quite different to HTTP, which is kind of request and response oriented. And this is, TCP is kind of like one of the fundamental protocols which the internet is based around. The other one you might have heard about is UDP, which we're not going to talk about today. But TCP is kind of like the reliable protocol. You send some bytes down it, and it arrives on the other side in order, without errors, as you expect it to. Cool. So what we're going to do now is actually make a really simple TCP client and server using Netcat. So who here has used Netcat before? Netcat, this guy up here. So that's interesting. That's about 40% of people. When I did this talk at work, it was about maybe 80%. So hopefully this will be more interesting for you guys and kind of you learn a bit here, which is kind of the point of this talk. So let me show you on the server side and the client side. Let me just reset this guy. So let me just show you Netcat, this command. Netcat is a utility used for just about anything under the sun involving TCP, UDP, and Unix domain sockets. And it can open up TCP connections. That means it can act as a TCP client. The other thing it can do is it can listen on arbitrary TCP ports. That means act as a TCP server. And that's exactly what we're going to make it do today. So on this side, I'm going to make a TCP server using Netcat. And that's pretty simple. I do netcat-l. L means listen. I'm going to listen on localhost. I'm going to do -p and then port 1234. Let me just search for that in my history because I might have forgotten. I haven't forgotten. That is it. So netcat-l means listen, -p means listen on port 1234. And then on this side, I'm going to make the TCP client using Netcat. So I can do netcat localhost, which means this machine. I'll talk a bit more about that in a second. And the port 1234. And that's it. That's what we have here is a TCP connection between our server and the client. And I can write to the client. I'll see it on the server. I can write on the server. I'll see it on the client. So let me give you a quick demo of this. So if I say, hello, my name is Apu. On the client side, I can see it on the server side. Hello, Apu. My name is server. And I can see it on the client side. And that's pretty awesome. In a couple lines of bash, we have a really simple TCP connection running. Our next step is to basically implement this kind of logic, or roughly this kind of logic, in Golang. So let's move on to the next bit of the presentation. So that's what we're going to do here. So let me just bring up some code that does this. So let's focus on the right-hand side of this code first. We have our main function, and then we call kind of two quite important functions here. We do first net.listen, and this guy takes in two parameters. He takes in this TCP string, which is basically the protocol we're listening on, and takes in this address string. And what this address string has is two things. The first is localhost. Who here has a good understanding of what localhost means? Roughly 30–40%, about the same number of people who knew what Netcat was. Localhost basically means this computer. It's a local host. And it's kind of like a DNS name. If you dig localhost, if you look up what localhost means, it actually means the loopback interface, which is kind of an interface running, not really running. It's not like a physical network interface like my network card on my machine. It's kind of like a conceptual thing which is inside of the kernel. And any traffic that's sent to localhost is handled by the kernel to be sent back to this machine. So essentially kind of a byword for this machine. If you were to kind of find out the IP address of localhost, it is 127.0.1.1, which is kind of this machine. So that's what localhost is. We have a port 1234. Think of a port as kind of a door to this machine. This machine may have many different ports, but 1234 is kind of the port we're going to listen on this server. Typically, HTTP server is listening on port 80, but that's a reserved port you need to use sudo for, and I'm not going to do that for you today. But yeah, and if you're using HTTPS, you will probably listen on port 443. HTTPS, of course, is the secure version of HTTP. But let's do 1234 because it's easy to remember. So that's what this address is. What does net.listen do? Well, it does a few things, obviously. The two kind of key points about net.listen is that the first function it calls in the kernel is bind. And what bind does is that it asks the kernel to send any traffic sent to port 1234 to this process. That's the kind of thing it's doing. So anytime I try to send any TCP traffic to port 1234 on this machine, it's going to be handled by this process. That's what bind does. It reserves this port for this process. The second thing listen does is that it calls a function called listen. And then let me show it to you over here. So just in case you don't believe me, if I do man listen, that's this function here. And what listen does is that it basically waits for a TCP connection to be made. So essentially waiting for somebody to say, hello, I am a TCP client, let's start up a connection. And that's what listen is doing. We take this listener object, which net.listen creates, and then we run accept. And what this guy does is that he runs the command accept inside of the kernel. And what that does is that he starts up a connection. So he takes care of handling the TCP handshake, which is something which I won't go into detail today, but it's basically kind of the creation of a TCP connection. It handles that handshake, and it gives to us the connection. And so basically, the whole process of starting up a connection, from binding the port to the process, to listening for new connections on that port, to starting up a connection and handing that off to user space, that's handled by these two functions. And that's what HTTP listen and serve, this guy over here, does. So that's what we've done this over here in Golang, using the net package. So at this point, we have a connection. This net.con object, we're going to put this in our netcat-ish function. We're not actually going to implement Netcat properly. We're going to do kind of a YOLO Netcat. What we're going to do is add the constraint where that you have to write on the client first, and then the server will display it, and then you write on the server, and then the client will display it. So it's client, server, server, client. Not quite what Netcat is. In Netcat, the client and server can respond at any time, but let's just keep things simple for now, because I'm going to reuse this code for the next step. So what are we going to do here? We're going to make a reader for the connection. So we're going to read from the connection, and we're going to read all the way until we see a new line. So that's going to give us all the text all the way up to the new line. And then we're going to basically print that out to the standard output of this process. So at this point, we've read from the connection, we've read what the client has written on the server, to the connection, and we're going to dump it to the standard out. The second thing we're going to do on the server is we're going to read from the standard input of the connection. We're going to read again to the new line. So this is super similar to the line a few lines above. And we're going to take that text, and we're going to dump it down the connection. We can do connection.write and just write it to the connection. And so then the client can see it a bit later on. Let's move on to the client. So let's just talk about this netcat-ish function first. Over here, it's actually very simple logic, similar logic to what the server is doing. The client first reads some standard input and then writes to the connection, and then it's going to read from the connection and then write to standard output. So that I hope that kind of makes sense to everybody. Really simple logic. The server's reading from the connection, writing standard out, then it's going to read from standard in and then write to the connection. The client's going to do the same thing, but in the opposite order. One more thing to talk about here is that the client, he does net.dial. And what happens to him internally is that he calls a Unix command, a POSIX command called connect. And connect is basically kind of the ancillary /sister/brother function to listener.accept. What net.dial does and what connect does is that it starts up a TCP connection. Whereas listener.accept is waiting for a TCP connection to be made and returning to us the connection. Net.dial is creating a TCP connection and then returning the connection to us once it's been made. And so that's what net.dial is doing. I'm going to run this code. Does that make sense, everybody, what we're doing here? Yeah? Cool. Let's run that code. So I'm going to go up in the right directory. And then this guy is going to go in the right directory as well. Cool. Yeah. Yeah. So I'm going to run the server. And then I'm going to run the client. Oops. That's my client. Let me just restart the server, actually, and the client. So I'm going to write something on the client side. I'll see it on the server, and I'll do the same on the server side, and I'll see it on the client. So hello, my name is Apu. That's the client sending it to the server. The server's got it, awesome. Then on the server side, I'm going to write something else back. So hello, my name is Upa, which is my name kind of backwards. And then the server sends it back to the client, and the client receives it. So that's kind of it. That's really simple code that does a netcat-ish-like functionality in about 30 lines of code. And so that's awesome. We have a really simple TCP client and server connection working in Golang. The next step is build HTTP client and server on top of what we've just done now. And so in the middle, we have our kind of familiar TCP client, byte stream, TCP server diagram. What we're going to build now is the kind of the HTTP components of this. So the far left and the far right-hand side of this diagram. And so what our HTTP client is going to do is that he's going to create a string that represents the HTTP request. He's going to serialize it down as a sequence of bytes onto the byte stream. The HTTP server is going to read from that byte stream, from that connection. It's going to reconstruct that HTTP request from that byte stream. It's going to create a string and reconstruct that request. And then it's going to do some logic. It's going to either get the Brexit date or update the Brexit date as we need it to. And then it's going to recreate a new response object. It's going to create that as a string. It's going to write that string to the connection. And that connection is going to be read by the HTTP client on the other side. And that guy is going to basically dump it to the console so we can kind of use it. That's about it. Before we go into the kind of nitty-gritty of actually running that server, what does a response and request look like? So let's just kind of get a good understanding of what's happening and what a response and request looks like. So a request is basically made up of a few different lines. We begin with a status line. That's pretty simple. It has a method over here, the endpoint we're hitting, the protocol version. It has some headers. Headers are really important in HTTP. I'm not going to talk about them here, but they're really quite interesting, and you can use them for really quite funky things. But we have some really basic headers here. We then have an empty line. It's actually something called a carriage return line feed, which is essentially kind of a hacky way of saying empty new line. And then we have a body of our request. And we're going to set the Brexit date to be never, because obviously we don't want Brexit to happen. Chuckle there. Maybe people do want Brexit to happen. I don't know. Our response is actually really similar. We have a status line that has a protocol version, a space. That's really important. We're going to use that space for a kind of string manipulation later on, in the same way that we can use this CRLF, this carriage return line feed and empty line, for string manipulation later on. We have the protocol, the space, this status code, which tells us the kind of the status of our response, status of the server, a human readable version of the status code, some headers, the space again, and then some body. So that's basically it. Let's build our HTTP server and client on top of our TCP server and client. So let me just cancel these guys and just go into this guy. So let's have a look at the server first. So we have our main function. Again, we listen. Listen, of course, does the bind and then listen. Get the listener object. Then we do listener.accept. That's accept. At this point, we have a connection which we can handle and do stuff with. We can handle that connection. And the first thing that we're going to do with this connection object is get some request parameters. So that's what this function here does. Let me just move this across so you can see all of this. This function is actually, it might look scary, but it's actually pretty simple. All it's doing, really, is taking that connection object and doing some really basic string manipulation. It's reading from that connection and separating on new lines, on spaces, on the carriage return line feed thing. And it's just doing some really basic, quite trivial string manipulation. From that, it gets a method, the URL, and the body. And that method is kind of one of the first parameters. URL, I think, is the second parameter, and the body is a bit further down after the kind of CRLF. So that's what this function does. We run this function. We get the method, the URL, and the body just from string manipulation. Pretty simple, pretty rudimentary. It works. We have some debugging going on. And then just as before, where we had a switch on the method, we're going to have a switch on the method here. If it's a GET request, what we're going to do is create the response. So the response is going to be the status, which is everything is good, some headers, and as a body, we're going to put the Brexit date. Then we're going to fully construct the response. The response is that status line, the headers, an empty new line, and then the body. And so that's exactly this guy that we're creating here. We're just creating this guy again in our code. And then we're going to take that string and then write it as a sequence of bytes to the connection. The put is pretty simple. It's kind of similar, actually. It's going to take the body of the request, and it's going to set our global variable, Brexit date, to be that body. And then it's going to write a really simple response back to the connection. So the response is going to be basically this, the protocol, status code, and then empty new line. And it's going to write that to the connection. And that's about it. That's our server done in 70-ish lines of code. And then let's have a look at our client. So client, let's have a look at what he does. He firstly dials to our server. That's what's happening up here. We then, just as before, we create our first GET request. And that guy is going to get the GET request, create the GET request. We're going to do the GET request, and then we're going to print out the Brexit date. That's what we're doing here. We make our status line. We add some headers. We create our request, and then we write that down the connection. We get the response. We split the response on the CRLF. And then we get the Brexit date. We actually get the body of the response from this GET request. And that's the first thing that we've done on this client. The second thing that we'll do is that we'll update the Brexit date. So again, we're going to dial to the server. We're going to make a new request. with put, and as part of the body of this request, we're going to make the Brexit data be never. I don't know if you can see this. This is the man with the arms crossed emoji. It hasn't come up very well, but this is an angry man saying never. So we're going to create this request object, the string, and then we're going to write it to the connection. And that's about it. That's basically our client done. So let's actually run this and get something working. So let me go in the right directory. And over here. So I'm going to run the client now. That's the client, sorry, that's the server running. And I'm going to run the client. Hopefully this will work because I haven't done any changes to this. So I'm running the client. Sorry, that's the server. I'm going to run the client. Awesome, the server's run. It says somebody's done a GET request, somebody's done a PUT request. The Brexit date is the 29th of March. Awesome, the PUT succeeded. If I run this guy again, it tells me the Brexit date is never, and the PUT has succeeded, which is awesome. That's basically a HTTP server and client running in Golang. And it's actually quite easy. It's really, 70 lines of code on the server and then about 50 lines of code on the client. But what I hope you kind of get from this is kind of an understanding that writing the server and the client actually wasn't very hard. What NetHTTP is doing is obviously more sophisticated than this, but really at its most basic is doing some string matching conceptually. It's just looking at the request, understanding what the different parameters are, and then extracting them out, it's putting them into a struct, and allowing us to kind of write nice application logic on top. So hopefully you have a better understanding of what NetHTTP is doing. Hopefully if something goes wrong, you kind of understand where things might be failing. It might be in the net.listen or the listener.accept, or it could be in the net.dial, these kind of key functions of POSIX. And yeah, hopefully you have a kind of better appreciation of networking as well. So that's about it. What did I talk about today? I talked about some debugging tools. So I talked about Netcat, which is really super useful. I didn't talk about curl, didn't have time, but it's also who here knows curl out of interest? Yeah. So how much time do I have left out of interest? I'm pretty close. Okay, so curl is a really useful function. You can use it for making HTTP requests. I really recommend it to you if you haven't come across it before. But it's super useful for debugging. I use it more or less every single day. For POSIX, we learned about some really important functions: bind, listen, accept, and connect. And it's kind of the kind of ancillary functions in Golang: listen, accept, and dial. We talked a bit about HTTP and TCP. Inside of Golang, I briefly covered what NetHTTP does and the kind of magic it has inside of it. It's pretty featureful. These are just some of the features it provides. The HTTP server we built today is terrible. It doesn't have any error handling at all, so it's going to panic at some point. But NetHTTP does things properly and has a bunch of other features which are really quite important. And about Brexit, what did we learn? Well, we didn't really learn very much, and we still don't really know what's going to happen. There you go. But yeah, thanks for listening. I think, do we have time for questions? Yeah, awesome. Before we start questions, could I actually thank Paul, Dom, and the rest of the log team, Antonio and Kath, for actually asking me to do this talk. It's actually really quite fun. I really enjoy the whole process. I'm a first-time talker here, second-time talker ever, and they're always looking for new speakers. So if you're interested in doing a talk, come and talk to these friendly guys. They'll help you a lot.
In the second example, in your folder for the receiving and sending, why doesn't it block and receive before sending? Is it both at the same time?
Yeah, could you just say that question again? So you said in the server side.
It's waiting for a new line character. So why doesn't that first two lines of code block and
So yeah, so the question is, why doesn't this first line of code block? Just to make clear what this line is doing, maybe I've not fully understood your question, but it's basically this guy is making a buffer reader, which is reading from the connection, and it reads all the text up until it's received this kind of literal, this kind of rune, which is the new line character. So it's reading continuously from the text, from the connection, sorry. And what the kernel is doing at this point is that it's giving basically bytes up to the user process, to our Golang process. And what buffer reader is doing is that it's reading from the connection until it receives that new line literal. Does that make sense? There's some, we can talk maybe offline a bit more about blocking and writing, but what the kernel does internally is that it has like a buffer for the connection, It has a buffer on the reading side and the writing side, and the kernel is writing to the connection and reading from the connection. It's assembling those bytes, getting all the packets in the right order, and then setting up a sequence of bytes in the right order without errors to our user process. Imagine that our network was really flaky, then this guy would block. But what's happening here, because it's on our local machine, everything's good, we're not dropping any packets, everything's happy, it's not really blocking. Yeah?
So what makes the later HTTP version so much nastier to implement?
Good question. The question was, what makes the new versions of HTTP so much nastier to implement? So there's two new versions of HTTP. HTTP 2, have people come across HTTP 2 before? And gRPC, yeah, some people. And HTTP 3, who's come across HTTP 3? It's very exciting, maybe about 20% of people. I'm quite excited about it. HTTP 2, it's been nastier because, so it's a stream-oriented protocol. Instead of just having simple requests and responses, you can kind of streamline multiple requests and responses onto the same connection. It has a bunch of new features. It's actually, it does things more concurrently as well, I'd imagine. So imagine the equivalent of our kind of TCP client and server is going to be handling many different things writing to it at once. So I think it's going to be much harder to implement. I also don't have as good understanding of HTTP 2. But HTTP 1.1 is really simple. It's really just string matching. HTTP 2 is even more complicated. HTTP 3 is actually not crazy complicated compared to HTTP 2. HTTP 3 is basically just HTTP 2 on top of QUIC, which is the new transport protocol. Who here has come across QUIC? Yeah, some people. Same people again every single time. You really like your networking, don't you? QUIC is kind of a new replacement for TCP. I don't know if anybody here has had the problem where they're using Spotify and they go from one network to another, and then Spotify just stops sending data or receiving data. That's because in TCP you have to do a new handshake every single time you move to a new network, and that's kind of a limitation in the TCP protocol. What QUIC does, this new protocol, it kind of relieves us of that limitation. It allows you to have a persistent connection, even if your client or your server indeed moves to different networks, and that's super useful, especially as that everything is mobile nowadays, and our servers might move all across the world. And yeah, HTTP 3 is just HTTP 2 built upon QUIC, which is kind of a replacement for TCP.
One last question. Yeah, can you go lower down the protocol stack to ARM and stuff like that?
Okay, well, sorry?
Are the packages which allow you to go further down the protocol stack below IP?
Right, you probably could. I haven't got that far myself, to be honest. I'd be interested to see what non-POSIX, what net.listen and listen.accept does in non-POSIX environments. That might be interesting, like what it does on Windows, for example.
Just thinking about getting capturing all the packets.
Right, yeah.
Like noticing a problem on a web server which should be hit by attacks.
Yeah, that might be quite interesting. I was actually thinking of doing this talk differently and actually doing that kind of stuff instead of what I've done here. But maybe another talk. Yeah.
Thank you very much. Cheers.
Thank you.